In this question, we're going to have a look at probability equations, and this is quite difficult because it involves ratios and forming equations, quadratic equations actually. So yeah, let's have a look at it. It's told us the ratio of red to blue counters is 3 to 1, but it hasn't told us exactly how many red counters and how many blue counters there are. There could be 3 red and 1 blue, there could be 6 red and 2 blue, so we actually have to represent this algebraically. We say that if there's X amount of blue counters, then there's going to be 3x amount of red counters. That way, the number of red counters is always 3 times larger. It also tells you 2 counters are removed at random. If 1 counter is removed and it doesn't specifically tell you that it's put back into the bag, then we always assume that it's not put back in the bag. So we're going to draw a tree diagram out to represent both counters being pulled out. So first of all, I'm going to have red here, blue here. The probability that it's red is 3x over the total of these two added together, which is 4x. And I'm not going to simplify this, I'll show you why later. The probability of blue is just the amount of blue, which is x, over, again, the total 4x. Now, if you pick a red counter, because we're assuming that we don't put the red counter back in the bag, the total number of red counters is going to go down by 1. So instead of 3x, we're going to have 3x minus 1 red counters. And also, the total number of counters is going to go down by 1. So instead of 4x, we're going to have 4x minus 1 red counters. However, if you pick a red counter, the number of blue counters stays unchanged. So there's still going to be x amount of blue counters. It's only the total amount of counters that's still going to go down by 1 because you picked a red counter out. Using that same idea on the second branch of this tree diagram, if you pick a blue counter, the total number of blue counters goes down by 1, and the total number of counters also goes down by 1. Whereas if you pick a blue counter, the number of red counters, 3x, which was initially in the bag, stays the same. It's just the total number that goes down by 1. It's told you that the probability that both counters are blue is 1 over 20. So if I just get my highlighter tool out, the probability that both are blue means you have to go across the tree diagram where you multiply across the individual branches. So let's do that. We say that the first probability, x over 4x, multiplied by the second probability, x minus 1 over 4x minus 1, is all equal to 1 over 20. When you multiply fractions, you're multiplying the denominators and the numerators in order to get the numerator and denominator of the answer. So we say that x multiplied by x minus 1, which will just become x squared minus x, just to neaten things up, all over 4x multiplied by everything here. So 4x times 4x is 16x squared. 4x times minus 1 is minus 4x, is all equal to 1 over 20. To solve this, we're first going to cross multiply. So multiply the top left by 20 and the top right by everything here. 20 times x squared is 20x squared. 20 times minus x is minus 20x. And that's all equal to 16x squared minus 4x, all multiplied by 1, which is just itself. Let's now take all the terms to one side so it's easy to solve. Subtracting 16x squared from both sides and adding 4x to both sides of the equation, we get 4x squared minus 16x is equal to 0. And now it's in a position where we can factorize it pretty easily because we know 4 goes into both terms and x goes into both terms. So we can say this is 4x lots of x minus 4. And this left hand side is equal to 0 either when x is equal to 0 or when x is equal to 4. Now that we've done the hard part of the question, if we go back to the original beginning of the question, we said that there's x amount of blue counters and 3x amount of red counters. It doesn't make sense for x to be 0 because then you just say there's 0 counters overall, and yeah, that's unrelated to the question. If instead x is 4, then we can say that, okay, well, there's going to be 4 blue counters and 3 times as many red counters, so 12 red counters. And so the total number of counters in the bag before any of them were removed, sorry about that line, is 12 plus 4, which is 16. Again, a very difficult question. This was at the end. Well, actually, this came up in a GCSE paper, but it also came up in an AS paper in the statistics section. So that's why I thought we'd have a look at it. It's a very difficult question. Let me know if you do have any questions with it. And if you'd like me to go through a similar one, just let me know in the comments as well.